Thank you very much indeed for joining us this afternoon, and good afternoon to you all. I'm glad you found the time to join us today. I'd really like to just take you on a little journey with our transit company, who are based up in Turku in Finland. And it's just an interesting story, but it nicely illustrates what people can do to build a MaaS system, and hopefully you'll understand how they did this and the benefits of them doing this as we go through the presentation. I guess a lot of you might know all about Init and what we do, but if you're new to Init, I just wanted to give you a quick overview of really what we do. Essentially, we design, build, operate, and maintain turnkey transport solutions. In essence, I suppose we deliver planning systems that people use to design their networks, fleet management, or as you more commonly say in North America, CAD AVL systems. We produce from that real-time passenger information. We build and distribute electronic fare management systems. Increasingly, our business is in providing business intelligence to people by analyzing what's happening in their network. But at our heart, we're a family-owned business based in Germany, and we're effectively a technology spin-off from the Karlsruhe Institute of Technology, which is the leading university in Germany for telematics. We've been making ticketing systems for almost 30 years. Originally, we started, as everybody else did, using conventional smart cards and paper-based systems. Over the years, we adapted that and we added things like barcodes, and we were able to cope with bank cards. But about 6 or 7 years ago, people started thinking about ways to add other features and functions to their ticketing system. And this led to the development of a concept or a technology called ID, or account-based ticketing. People say, oh, what's this? Definitions, etc. I'm quite old, and when I traveled as a much younger person, when you went to the airport, you took your aircraft ticket with you. You quite often had a little envelope in which it came, and in the really old days, it was handwritten on stencil paper, and you went to the desk and someone opened the ticket up, and then they understood who you were and what you were trying to do. These days, though, when you go to an airport, you don't take a ticket anymore, you take your passport. And this is the same concept, basically, as we have in account-based or ID-based ticketing. You take your passport because it's an ID. And that ID allows the person on the ticket desk to access what you've bought, what you're there for. So you don't have a ticket anymore, you have an ID, and your ID is usually a passport or an ID card, and that accesses all the information about the journey you want to make, the fare class you've bought, and all your rights and everything else, but it's not on a ticket anymore. It's in the back office. And this is really the essence of ID or account-based ticketing. That's by the way. But essentially what we do in transport ticketing then is we move the smarts from the card into the back office. And this created many opportunities to do some different things in ticketing. One of the opportunities this created was the ability to connect separate systems and system elements together. And this was done really through the use of APIs. And APIs are just defined programming interfaces that allow different elements of your transport system to communicate in real time and in a bi-directional way. So your planning system is linked to your operational dispatching system. Your dispatching system can be linked to the ticketing system and to the passenger interface. And this means that we're able to achieve a single unified transport application for passengers. So when you're using an app, it's really as a result of connecting all the underlying data systems together in a live and real way that allows dynamic information to be exchanged with passengers in real time. So if there are delays, if there are operational changes that are made, if you change ticket zones, etc., all of this is happening in real time and known to you through your application or through the website, because it's a live, dynamic, living data system that you're accessing. But the passenger doesn't see that complexity. The passenger just sees the application or the website that they want to use. So we've linked all the elements of the system in a single mobility chain. But we need to spell a little bit of caution here. Linking all these changes together makes some fundamental assumptions about the quality of the data that's in the system. And if you've got multiple systems working together, one of the essential elements is that there's consistency right across the data network that you put together. And you might have different sources of information of different qualities. And one of the important things to do if you want to build a MaaS system is to build a data network where all the information is properly coordinated, properly synchronized, so that the information the passenger's getting on one mode of transport is exactly the same quality of information as they're getting from the other. And this really means that the planning has to be good. Planning is theoretical. Planning is impacted by all the things that happen in our cities every day. And so the planning needs to be complete and accurate and realistic. One of the ways we make planning realistic is we use fleet management systems. And in our fleet management systems, the dispatchers who work in our control rooms are altering what's happening. And when they're altering what's happening, when they're curtailing a route or when they're diverting a bus or putting a diversion in, it's really essential that the passengers that are going to be consuming this information are informed automatically. If we have operational dispatching and we have planning, we can then make a really good prognosis on when the bus will arrive. If there's diversions, people know, and we can tell people what the alternatives are. If we add to this then travel planning and the complexity of some of the marketing things we try and do in ticketing systems these days with things like best price, fare capping, it might be that passengers can choose the fastest journey. They might choose the greenest journey. So we give them a calculation of the CO2 emissions that their chosen route makes. And even now you can do things like you can give passengers the option to travel the driest journey if there's a weather event and they want to avoid it. All of these things are possible. The other thing that we really need to do then is simplify the information that the passengers receive. We can individualize it and tailor it through applications to give them information about their chosen journey, and we give them information along the route. And these days, with the advent of Google and iOS and things, it's really easy to get people to be able to customize the journey and the journey patterns they want to do and provide them with highly tailored information about what they want to do, all in one single application. And this is really what MaaS systems are doing. In order to do this, though, there's had to be some development around the way that we store, we share, and we standardize data. Many of you will be familiar with GTFS, the static data that we use to describe bus stops, bus routes, etc., etc. GTFS now comes in many flavors and has been extended to allow us to provide not just static information, but real-time information, not just on bus networks, but on congestion. It allows us to store elements of the ticketing system in individual legs of the journey. So if people are making a multi-leg journey on different routes, the app can understand the elements of the ticketing and what people are entitled to, etc., underlying everything else that's going on. You might think really about this in terms of another comparable, which might be an air journey. When you have a flight and multiple flights and there's a delay or there's a cancellation, the reason why you can be transferred to another airline or a later flight, etc., is because the underlying data systems know what you're trying to do. And when you go to the ticket desk to rebook, etc., that information is known and exchanged. If we're doing that in public transport, then we need to embed that into the data systems. So when something goes wrong, the passenger is guided through the system in a way that's consistent with the way that they want to travel. And by extending the data attributes in these systems, we're able to offer that tailored service to an individual passenger in a transit system in the same way as we can do with an airline. There's lots of good work being done on this around the world. Some of it notably in Portland, one of our customers, so we know that very well. But in many other places around the world, there are academics and industrial organizations that are working on solving these complexities. That's by way of sort of introduction to what happened in Finland. About 6 or 7 years ago, the area of Finland around Turku, the municipalities came together and they decided that they wanted to collaborate and create a new brand for their public transport in the region around Turku. The idea of working together was to share their resources and allow everyone to access the system that they wanted to use. What did the project really consist of? Well, the aims of the project really were to make it easy for the passenger to travel and easy for the drivers and the other people who work for the transit organizations. And the project was built on an open architecture, and that's quite essential, and you'll see the complexity of the project and why an open architecture was really the core of solving the technology problem. They knew they wanted a new CAD AVL system. They wanted to provide better information and control for the operators, but they knew they wanted better passenger information, so all the people across the 6 municipalities could have the best possible information, build trust in the transport network, and encourage people to use it. The other part of the system was we put in a traffic signal priority system, and that was the first part of the project we did. We then added a ticketing system, which was an integrated multimodal, multi-operator system. And we started this in about 2014, delivered in 2016. One of the key design and guiding things was the system had to be flexible, open, and expandable. And the way we did this was implementing our first account-based ticketing system. The reason being that was to provide something that the passengers and operators could easily live with and improve services going forward. When the municipalities started the project, they knew some of the things they wanted to achieve, but not all of the things. So they said to us, well, we might want to add other services, we might want to add other ticketing components, and we might want to add other non-transport attributes to the system. And so that was really what we designed. Even now, we're updating the system. This year, we've added the extra feature of EMV, or open loop ticketing, the ability to use a bank card, an international bank card in the system. One of the key things that they wanted us to do in the design and the implementation was that we had to seamlessly migrate from their conventional ticketing system to the new account-based system. And in order to do that, we supplied the new equipment and we made it work in a conventional way. After the system was bedded in and running successfully, we were able to basically take the smarts that are on the card, including the cash, and move it to the back office. And we did this in such a way that the people using the system were not aware of any changes. So we took the existing system and we mirrored it in an account-based system, and we made it function from the user point of view in exactly the same way. After we'd done this, we then started to add new fare products and new fare types. So we added in mobile ticketing with top-ups, and we made transactions all in real time. And the passengers saw no difference in the way that they used the system. They kept the same cards, but just the way the logic was done, where the logic was done, changed from being card-based to being in the back system, and therefore we achieved the account-based system that they required. A vital component to doing this and to connect all the different parts of the legacy system together with the requirements that we had to expand the system in the future led us to creating a set of unique APIs that allowed us to integrate the existing system, services and providers with the new environment as we went forward. This allowed the providers to offer a system where the consumers got the products and services in a way that they choose through a MaaS interface or gateway. I apologize for this slide. It's very complicated, but it's kind of unavoidable because it was a very complex project. The reason for that is that the elements that are shown in blue were existing parts of the old system that they wanted to keep. And so they already had sales channels, web shops, auto top-ups, sales points. They already had a back office that did the clearing, statistics, and travel. And they wanted to keep that. And they then wanted to add in things like mobile payments. And that's what we were able to do. If you look at the center of the diagram, the bits in green are the central init system. The two-ended arrows that surround that are the APIs that we use to connect the separate parts of the system to our core and to exchange information between all the parts of the system. And what we're able to do with the core of the system is we're able to manage the data in a consistent and reliable way. And we're able to combine all the existing elements, make it work in the new way, and then we were able to add the rest of the system. And so initially we built the fleet management system that you see in the middle, We then implemented the ticketing system, which is Mobile Vario. We supplied the system to the buses and the vehicles first, and then we were able to join all that together. We then added the attributes of the ferries, the taxis, the car and bike sharing, and just this year we've added the elements of the contactless or EMV system that allows people to use bank cards. All the time this is going on, of course, there's the passenger interface with the travel planner and the passengers. And so people can consume this data and consume this system through apps, through websites and everything else. And one of the things we also added into this is the national travel card of Finland, the Valti card. And people can just consume all of this in a single system through a single app or a website that gives them access to the MaaS services they can consume in the way they choose to consume it. One of the key things we realized going forwards that the operators and providers wanted to provide services with their own branding, their customized interfaces where they existed, and that passengers wanted to consume things in a way that they chose, so they could use different applications. So we just built interfaces that people could log into and they could tailor the information that they wanted to use in a variety of different ways. And it allows different parties that use the system to use it in a way that they choose to consume it. But all the elements are linked together, and that's really important because one of the key things is consistency and reliability of data and all the links that make up the passenger system. And the passenger experience is consistent however people use the system and whichever parts of the system people choose to use. So we delivered a system that was multi-client system. We integrated the travel planner, the mobile ticketing, the bike share, the taxis, and other things. But the story didn't end there. We were asked to create a system that was future-proof and allowed the flexibility to add more things in going forward. And one of the things that Turku wanted to do was they wanted to market different things combined with public transport. And so they introduced other third parties into the system. And there's interesting features to the system now where people can book a theatre ticket. They can have a meal. They can have public transport that takes them to the event, and they can get a taxi home all through one application, through one system, and that really demonstrates the flexibility of the system, is that they've been able to easily add third parties into the system and add diversity to what's available through the system. And it just really illustrates the flexibility of using the APIs to connect different parts into the system. So, like many transit authorities, I suppose, there were extensive customer surveys done to really see if all the technology and all the combining met customer satisfaction. Well, the surveys that they did showed that the new system was the most popular thing that the local authorities had done in the years that it was done. There was increased focus on driving the business by using the system. The feedback from passengers was it was very easy to use, whereas previously they had 6 municipalities multiple operators and different ticketing systems, people could just travel freely through the system. They got information about connections and connected journeys. They could use all the different attributes, such as the ferries, the taxis, and everything else, all by using one system and the cards. So the feedback from customers was very, very positive. The satisfaction was very high, and year on year, they're seeing about a 5% growth in ridership. That really sort of concludes the telling part of the story, and I guess now we open up to maybe taking some questions.